Hey, good morning, Simon, Namrata. Good to see you.
Oh,
We're down to two students
morning.
now. But you know what? What is? All right. So you guys tell me. Is this the same in all of the other classes also that you are enrolled in? Like, you must be in other classes too, right? I mean, you have lectures, or
Yeah,
you don't
yeah.
have lectures, other classes, everything else online.
No, we have other classes.
You have other classes, right? Namrata, you too
Yeah.
at UCSC, right? Are students attending those classes, or or
I
is
don't
the
know,
attendance
but like
dropping
just
off?
only two people. Like first, when I come into this room, it's only me, and it makes me confused. And I log out and check, is this the
No, no,
right
not this class, not
right
this
spot
class.
and everything? And it's yeah, that's it. But like no one's in here.
No, I know. I don't mean this class, Simon. Your other classes, like your other classes at Foothill or
Other
UCSC.
classes, I have one offline classes, and the other one is online. Yeah.
They're all right. Okay, so so what about you, Namrata? Your other classes are also showing healthy attendance.
There's there's a lot of people because the class itself is really big, but then like for the actual like percentage of who's showing up, it's like it decreases every time.
I see. Wow. Okay. All right. Yeah. But there is also there is about this class in particular. I know that students talk in Discord and even on Foothill, the Foothill Reddit. They talk about the difficulty. They say, oh, you don't want to do Anand's class because it's really hard and you won't get an A and things like that. And so lots of people are asking on Foothill, if I want to enroll in this class, which is an easy A, which is an easy A, which instructor should I take? You go to the Foothill Reddit, you'll see lots of students asking, even on Discord, saying, what is an easy A? And the students will respond saying, well, take this professor because, you don't have to do a lot of work and you get an easy A, easy assignments and so on and so forth. And I never see that for my class. Nobody says, take this class, is easy, and also I think I've heard a couple of people saying that this is a really hard class, but it is not a hard class. This is the class, this is the standard at which the state expects students to learn. This is the basic standard at which these are the materials that are supposed to be presented to students, and they're supposed to learn. So I don't know how, unless I'm teaching in a fundamentally difficult way, meaning it's how I teach is not easy for you guys to assimilate. In that case, I need to know, right? I need to know. Maybe if you need me to do the usual dance, like with slides and saying, well, that's what happens and so on, and or maybe it's the assignments. I think that's probably one of the reasons. Whereas because in other classes, even in my own class before I started the new way of teaching, people would hand in assignments and I would grade them by hand, and there's no way you can catch all the bugs by looking at a code. By looking at code. Yes, you got to run the code because there's so many corner cases that your eyes won't pick up. And so I think it is very easy for students to submit a printed program and say, well, I got full marks for it, even though it is actually technically not correct. It won't pass. There's so many cases that this algorithm won't work. So the algorithm doesn't show, understanding of the concepts, just following a recipe from somewhere, right? So maybe that is a possible reason that, you can't get the assignment points until you got bulletproof code. That, any code that you write in my class that passes all of the quests, all of the mini quests, you can be 100% confident that it will pass with flying colors out in industry, right? So if you go to Google or Microsoft and say, if you have an algorithm to code and you code this, it'll just pass all your peer code review, just like that. Okay, they'll say, well, all done all the right things. Okay, and it's clear. Because it actually prepares you for this kind of thing. Yeah, that is what I think computer science should prepare you for. Why you're learning computer science for two possible reasons. Okay, if you're learning computer science just to make money, I think that is not the right answer at all, right? So that you should not be learning computer science just to make money, because if you want to make money, if your goal in life is to make lots of money, there's lots of other ways in which you can make lots more money, right? Well, actually, that's not true. You can make a whole lot more money if you know what you're doing in any field, but on average, you can make a lot more money with in certain other fields. Okay, and so that is not the right reason. So you're learning computer science either to do some really cool stuff out there in a big company, meaning get or start your own company, or you're doing it to gain a skill set to give a forum to some beautiful thing that you have in your mind. Okay, so you have in your mind a finished product. Maybe, even at school, even in high school, maybe Hana has an idea for an incredible product. Okay, and so she knows already that, I need these skills to get to that. So I'm going to pick up all these skills one by one in college and so on. It'll get me to that place. Okay, so you're learning skills to build a product that you already have designed in your head. Okay, so that is one of the reasons. And the other reason is, well, I don't have an idea or a product, but I think I want to learn these because these are useful for out there. Because when I go and join a company, I'll get more ideas and I'll get to work with other people, brilliant people who also have great ideas. And then so those are the two reasons. And for those reasons, you really need to get to the bottom of the algorithms and learning how these things work, how to shuffle pointers and things like that. And it's not enough to have book knowledge. And I don't know how to counter this in community colleges. I don't know about, the four-year institutions especially, but community colleges, the thing is, for one of these challenging sections, you have three competing easy sections. Even, next, look at the spring quarter for CS2C, right? You have one CS2B, which is challenging, which is, I think it's mine. And then you also have two other CS2Bs, which are easy. And so those tend to fill up really quickly because everybody asks, well, what is an easy CS2B I can do, right? And they fill up, and our CS2B is not getting filled up. And actually, and because of, I don't know, I think maybe it is just short-sighted or silly, unwise administrative policies, right? Not far-sighted, not leadership-oriented administrative policies, just saying, well, what can I do to just keep my job? And those kinds of policies will tend to favor what gives me most enrollment. So, so that I can show the government, so I can show the people saying, hi, we got so many people through the door in our college. So it's a great college. So that kind of policy will say, well, you know what, if there's a challenging class and people are not enrolling in it, and so we cancel the class. And so we'll just run the easy sections so that lots and lots of students will come and get free A's for $150, right? That's really what it is. If you enroll in an easy section, you're buying an A+ or an A for $50 or $150. And that's a really stupid way to waste your money and also to run a college, really, I think, because that doesn't set the stage for creating successful and happy people out there. It just says we want people to come in and go out the door so that you're not our problem anymore. You're the problem of Google or Microsoft, whoever hires you, because you don't know enough. But we are not our problem anymore. So that is a short-sighted approach. And so the reason I say that is because our CS2B class is at risk of being canceled, right? And all of you guys, many of you guys, some of you are not here, Erica and all, they've enrolled in my CS2B, right? I think all of you have enrolled in my CS2B, most of you, I think, right? Yeah. And the problem is that the easy sections have gotten full, and so they don't have any risk of getting canceled. But our class could get canceled because it hasn't met the threshold. And then you'll be forced to do an easy section and learn all this stuff on your own, and which I don't think is a fun thing at all. So either the policy has to change, or the students have to decide, saying, well, I came to college to learn. I didn't come to college to party, right? Yeah, Hannah, you have a question?
I really need the credit for another class, but if how many people need to be enrolled for it to not be canceled?
20 students need to be enrolled. But the thing is, 20 by, I think they look for 20 by census date or something like that, which means that, we need to have slightly more than 20 to start, because, obviously some students will drop. Yeah. And so we don't want Foothill to be stuck in a situation where, you have a lot of students, so the class didn't get canceled, but most of them dropped and there's only 5 students left. And then, and that doesn't make sense for Foothill, right? Well, it makes sense in the sense that, the job of a college is to offer knowledge, right? But maybe it doesn't make economic sense for whatever, administrative model people have. And so they say, so we need to have at least 20 students. And so that is a risk. Already, I think my CS2A section for next spring, for spring, is at risk of being canceled. So I think my CS2A section only has 10 students. And so I don't think there's any chance it'll run, so it doesn't matter because it's, I just offered to teach it as an overload. Yeah, I don't have to teach it really because my spring load is already full. And it's like, yeah, I'll do CS2A also if, if the students are interested, but, their students are not interested for some reason. So that is a problem. I need to get to the bottom of that. People need to send me emails saying, why is it that students are finding it, prefer to enroll in some of the other sections. And, it's more puzzling because in CS2B, I look at the discussions and my, meetings with other students. They're always complaining about the other CS2A sections, saying, well, you know what, when I got into CS2B, I did this other professor CS2A, and they didn't teach me anything. They only got to objects and let me off from there, right? And they didn't, and so they're really struggling in the first few weeks of CS2B and saying, well, I should have done a hard section in CS2A when I could have learned all this thing. All these things, and so I could do a proper CS2B, and so that is not happening. So I hope it works out, especially because I don't expect to be teaching for well, I don't know, a few more quarters maybe, and I hope that as many people as possible are benefited before I go, and it's also fun, right? Because even after I retire. Even after I retire, I'm going to be looking at Reddit and all these places and saying, hey, are people questing and having fun, because it's fun for me. And the more people who already who go through these pathways and learn the essentials, the better it is set up really for them to just get together later on in life, saying, hey, you know what, we did some really cool stuff in college together. Let's get together. And because I know that from Reddit, I know that you made some really, really interesting posts. And so that I think the idea that I have, I think you'll be a great partner, right? So people will reach out and things like that. Those kinds of things will happen when we have rich classes, lots of students interested in the subject and having interesting discussions. So that's really what I'm, that was my initial, let's say, design goal. When I, created the system saying, let's have students have some fun, and then they'll get their points. They don't have to wait for me to grade and give the, grade back to them, because that was all a pain point. Previously, when I used to have students submit, they'll submit it and they'll send me emails saying, hey, professor, my fifth lab finished. Can I have the results? Can I have the graded thing? So I want to look at it, and they'll be impatient and ask and all. And so and I said, what can I do to make sure that the rubric is clearly exposed so that people actually know, right, instantly, and they get hundreds and hundreds of tries. They can just keep trying and trying and trying until they get it right. And when they get it right, they get an aha moment. Think, wow, okay, that is what I learned. Everything you pass, you'll actually get a real feel, saying, well, I really understood that, not just, paper knowledge. I really understood that. And so I think it worked for a little while, at least. And I think it's working with you guys because, I see these interesting posts, and also with my 2C and 2B currently. But certainly, I think popularity-wise, student popularity-wise, I think that students are gravitating away in a way, right? Saying, I do get some, the students I do get after the doubtful students drop off, the students who I do get, they're really strong students like you guys. Okay, the guys who actually get into class despite knowing it is a hard class, they are really committed and interested. And I see, of course, especially from you guys, in class right now, the ones who are in class, they're actually making interesting posts all the time. Whether I tell them to or not, they're trying things out, making interesting posts, trying things out on their own. Variations of things that we do in class, they post these things. Those are the marks of a successful future computer scientist or a software engineer, because they are intrinsically interested in the subject, not because someone told them to, not because out there all these successful people are computer programmers, so I also need to be a computer programmer. Or they're actually interested in the subject. Okay, and you guys are doing that. So same thing in 2B and 2C also. The guys who are getting in are, many of them seem to be, well, an overwhelming proportion of them, as as the quarters progressed, seem to actually be interested and doing interesting things, making interesting observations and all. But unfortunately, because only those people get in, and the proportion of those people is limited, the class sizes are also shrinking, which puts them at risk of being canceled. And which is really unfortunate, because we're canceling the classes for the people that are really interested in doing the class, rather than people who want to just get a paper degree. And so I don't know, maybe this problem will resolve itself. And so that is why I think I kind of favor some of the traditional models of education, right? So like in India or ancient China and many of these places, right? Iran, everywhere. So these places had traditional models of instruction where, you go to a guru or a teacher who actually knows what the hell is going on, okay? And they can teach you. And it's not like they have to come prepared to class. I know, music teachers, for example, in India, like I know I have many of my relatives, when they go to music class, they don't go to a particular hour or something like that. They're just hanging around in their teacher's place. And all of a sudden the teacher would say, well, I got some free time now. I just had my dinner. We'll sit down. I'll teach you something. Okay. And they teach a new song, right? The new ways of approaching things, new techniques and these things. This is when they have free time, they teach because they know how to do it. They don't have to prepare for it beforehand. And that way they only teach the interested people who are interested enough to hang around and say, well, you know what, I'm grateful for any knowledge I get. I'll just hang around. When you have something to give me, I'll just imbibe it because, it is gold. And so that is the kind of instructional technique that actually works to build strong students, not just students that are successful on paper and make a lot of money, by hook and crook. And so see if you can come up with any ideas, bright ideas for encouraging that trend, okay, and making sure that lots and lots of interested people enroll in these classes. Certainly before I retire, I hope to see an army of these incredible computer scientists out there, okay, out there, and so that I can after I retire, in a year or so, I can just sit down and watch all these people. They enough entertainment for me. Because even in this one quarter, when I teach, CS2A, I had so many fantastic moments when, we did something in class, and then Hana, Namrata, Erica, all of you guys, right? Every one of you actually in class, they've posted some variation of that, and I go and try it. And it actually gives me a real pleasure to see these things, saying, well, you know what, we only did this, but this student went ahead and took that to the next level. It is so fun. It is so fun for me to see. And then, so I've just built up my entertainment for the rest of my life after retiring, if I have a really good batch of students out there, because I just follow you, right? I can just follow you and say, well, you know what, what are these people doing out there? What are these people doing out there? Anything interesting came out from, these people, I can go and try it out. And so those are really things, not just me, okay? Every professor really is just looking for out there maybe after they retire, right? So they're all obviously interested in what they're doing, right? So interesting things they're doing, creative stuff they're doing. But, when they have free time, they're just going to browse and say, well, you know what, let me take a look to see what my previous students are doing, okay? And if they do something really cool out there, it's fantastic because, these professors can actually try them out and saying, well, I'm not just trying a random product developed by someone I don't know, but I'm trying something built by someone who I've talked face to face to, right? So, hey, Karthik did something, and I know Karthik from in my class, right? So I'll go and try it out. Obviously, right? And I'll make a comment saying, hey, Karthik, that was fantastic, man. Thank you, right? So those are the kinds of things that all professors are looking for in any college, not just Foothill, okay? Any institution, any research institution. So so see if you can come up with any ideas to increase the enrollment count for our classes. But otherwise, it's 8:20 today, right? We can start coding. So today's plan, I think we'll pick up last week's code. And I think we left off with an interesting challenge, saying we have these two sorted lists. How do you merge them to create a sorted list?
I posted something on the subreddit.
Oh, you did just now, or?
Oh yeah, like 5 minutes before class. Sorry.
All right, okay. Because I didn't see. All right, let me take a look. Okay, just give me 1 sec. But you guys can continue to talk. You can ask me questions too, because my ears are open even when my eyes are looking at the screen. I can look at. So yeah, feel free to ask any questions. Hey, where's the Reddit gone? Oh, there it is. Oh, combine two sorted lists. There you go. Oh, actually, you know what? I didn't have to refresh my page, because my Mac certainly it crashed this morning. When I opened my Mac this morning, it was locked up and it was it crashed. I think it's only done this like 3 or 4 times in my entire life of the Mac. I've had this Mac for 10 years now. And I've probably had to reboot it a few times. All right, you posted Hana. That's great. I took the code from last class. All right, yeah. Okay, fantastic. Excellent. Okay, that's exactly what I wanted. I'm not going to look at the code, Hana, because I think it is probably correct. Because if you got it right, if you got it to work, and you also mentioned that it is linear in the time of the two sorted lists, it is probably the right solution. So I think what we'll do today is I'll take a look at it later. Okay, Hannah, but maybe today someone else who wants to do that. So Hannah will stay quiet. Okay, so you don't have to, when we're coding today, don't you can obviously fix errors like everybody else and say, hey, this here, but don't give away what you did, because I'd like whoever is coding to figure it out. Not whoever is coding, everybody other than Hannah should also figure out the idea. It's actually a very simple idea, okay? But it takes a little bit of insight to see how I can do that, because there's two ways to do it. One is quadratic, and the other is linear. And that linear way is what Hannah did, and that's the way you should discover, okay? So how about this? Today's class, someone pick up last week's code, not the code that Hannah shared, okay? Pick up last week's code, and then you are going to implement, okay? You are going to implement this. And how about I give you, I don't know, 15 minutes, 20 minutes. I don't, it doesn't matter to me. Okay. You tell me, and and what you're going to do is get the code and say, we want to do this. I want to write a function that will blend the two lists together. How do I do this? And you may need to implement some other methods if you need, okay? You may need a method in your list class, saying, well, get the first node and get the last node and things like that. Because you are storing the first node and the last node. Yes, in your list class, you have a pointer for the first node and you have a pointer for the last node. Yes, that's how you implemented it last class. You guys forgotten? Because I didn't do it that way. You guys did it that way. So in the last class, if I remember correctly, when you implemented the list, you had a list with a node, and then you had a pointer to the first node, and you also stored a pointer to the last node. Yes, in your list class. Okay, well, and it doesn't matter. Okay, you'll find out. Maybe you need to write two more getters saying, well, get me the last node, get me the first node, because you may want to use these things. But if not, just feel free to implement it. It's not just the person who's coding. Remember, okay, the person who's coding is mainly in the capacity of a typist. Everybody else should feel free to say, well, you know what, if we want to blend the two lists, we should try this. Here's an idea. We'll take one node at a time and peel them off and stick them together, things like that. Or you can take one list and say, take the other list and take the first element of the list and keep scanning the first list until you get to a place where that element should be inserted at that point. Okay, and then take the next element there and keep scanning forward and so on and so forth. You don't have to go back, because anytime you've inserted one element, you know that all the elements after that, well, I shouldn't tell you more because I'm just really taking the juice out of the apple here. Okay, so those kinds of things are the really fun things you'll discover in the process of doing this solution. These are discoveries you'll have, and these discoveries, the sweetness of these discoveries are what will nail the algorithm to your head. Okay, so just the fact the algorithm works at the end and gives you a boost and a high, well, okay, it is some form of feedback that says, okay, it's a cool thing I need to remember. Okay, but what I've found is that it is not just the final outcome saying, oh, it works. Okay, that's not the thing that really cements the algorithm in people's heads. What really cements the algorithm, any technique in people's heads, is not the final aha moment, but all of the little ahas that you go through, saying, well, you know what, this pie or this ice cream is not sweet. The last spoon is not sweet. Every spoon is sweet. Okay, and so you say, well, you know what, in the process of getting there are so many cool things. And so that is why this is right. Same thing with melodies too, right? So if you want to learn a melody, as you identify lots and lots of little phrases, lots and lots of little spots that are fun, right? And really beautiful and to listen to. So it's not just the whole thing needs to be good. And so that is how you remember things and saying, and so I would like you to have that experience if possible. So how about today, who would like to pick up the screen and code? Okay, and anyone can. Okay, so Sabrina, you want to also? That's fine. If you want to, you can code. You don't have to code, by the way, meaning that you will just be in the mode of a typist, and people will call the code. But if you do have ideas, you can code. You can ask questions, saying, "Hey, what should I do here?" And other people will chime in. If nobody has an answer, I'm happy to have come back and tell you. But Hannah has already implemented it, so she will be able to help out too.
Wait, after, could you look at my code and correct some style stuff?
Yeah, totally. Oh, you mean today?
I don't know, maybe just some.
Yeah, sure, absolutely. Right. How about we look at your code after we have a working version of someone else's code? Yeah. So after we have a working version of someone else's code, we'll pick up Hannah's code, and it'll actually be very interesting and useful too, right? You looking at Hannah's code after you've done your code is useful because you'll have the two approaches. Maybe they're the same. If they're the same, it'll just be reinforcement for you, saying, well, that is the approach that most people tend to pick. because that is better or something like that. Or if Hannah's approach is different, you know, well, you can do it in 2 different ways and they're both linear or they're both fast, both, right? And so you'll be able to look and appreciate different ways of doing the same thing. In programming, there's many different ways of doing the same thing, okay? In fact, there used to be a programming language called Perl, okay? P-E-R-L. I don't know how many of you are familiar with this language called Perl, okay? And one of the sayings about Perl is that it was so popular, apparently, because I did Perl. It was it was a very ugly language in the sense it didn't let you do nice code in like C++ or even Python. And saying there's many ways to do it, right? That was their motto, right? Perl says, there's many ways to do it in Perl. And yeah, okay, there's many ways to do it in any language, but Perl says there's many ways to do it in many things. And I don't know if that was a boon or a curse to programmers, because many ways just means many choices. Having many choices is not the answer to finding anything in life, including happiness, I think, right? Because having many choices means, well, there's so many things I can do. What should I do, right? So total freedom is not freedom at all. Total freedom is basically a prison, because total freedom without direction, where you need to go, is useless, because you could go in any direction. What you need is a playground where you say, well, you don't have freedom in this playground to do anything at all, but there's a structure, this play structure. You can do these fun things here. There's another thing, you can do fun things there. Okay, so then that's fun, because there's a small amount of rules. That's why in music also we have these scales. Even though you have so many notes, you can just punch notes at random. You got to punch notes according to a certain rule, right? These scales, these notes follow each other or something like that. Okay, then it starts sounding nice. So total freedom is totally is a handicap for programmers. You need to have some subset of ways to do these things. And also that means if you have some subset of ways, you would also have the ability to approach it analytically, saying, well, I only have 5 ways to do this. So which way is the best? You can ask that, right? If you only have a certain number of ways, you can analyze each of those ways and say, this is the best way. This is, this only takes 10 seconds. That takes, 15 seconds. But if you have, 5,000 ways of doing things, nobody's going to say, oh, I'm going to analyze each one of those 5,000 ways. You can't. So that is why total freedom, meaning lots and lots of different ways, doesn't really help. You need to have some subset of ways. And so you can actually look at these ways and say, well, that's better, that's not so good, and so on and so forth. Okay. So, right. So who wants to take the screen and code today? So someone other than Hannah, please volunteer and take the screen. Yeah, Matt gone off camera now, but you're also free to take the screen. Okay. So who wants to code? Who wants to code? We only have one more class this quarter, right? So on Thursday. Thursday is the last class of this quarter. And after that, I probably won't see many of you until you get into CS2B if we run it. And in 2B, which is not it's not face-to-face, it's online, we'll still make opportunities to meet face-to-face. Like in my current 2B, which is also online, I have a weekly meeting. And I say, I'll come to the meeting if you guys invite me. Okay, so sometimes the students don't invite me because they just want to talk about algorithms and stuff. But when I'm invited, I go, and it's usually fun to watch these meetings. So. Right, so who take these opportunities? Who wants to code? Who wants to code today? Right, so you just have to pick up the code from last class, fork it on GDB. And thank you, Sabrina. Okay, thank you. Right, so Sabrina will code, and in fact, what I will do is I'll just move out of your screen. Okay, so I won't be in front of your screen. I'll just well, it's raining, so you can watch the rain and code. Right, so I'm going to turn the laptop around to face the yard.
The one from last class.
Who coded last class? I forgot who coded last class. Do you remember who coded last class? Was it Simon?
Is it 314 was the last one?
Yeah, Namrata's nodding. So yeah.
Yeah. Okay. Let me just go on. Get the.
How could it be 314? Because 14 is like 2 weeks before. But we coded. Yeah, no, 14 is one whole week before. That's Tuesday, but we coded on Thursday.
I don't see a code in the Reddit for 316 though.
Oh, Elijah coded last class, I think. Elijah, did you code last class?
Sorry, what?
Did you code last class?
No.
Well, nobody has the code for last class. Okay, how about you? Hey,
I have it. I think I have it.
You have it? Okay, thank you, Namrata. Okay, if not, we would have gone to the stack code from 3.14, the one that Sabrina mentioned, and then you can pick it up from there too. It's not a big deal to rebuild it, but yeah, pick up the link that Namrata will share, and you can, right? I'll stick around for just 1 minute after you share the screen, okay? Just to make sure that the code that I can still remember and understand what's going on. After that, I'll turn the laptop around for about 15 minutes where you can code. You can call me. You can call me anytime. I'll come back. But you should have a discussion. Basically, you've had previous classes too. I've seen when I'm out there, I hear you guys talking, and it's really interesting discussion. So you should just have a discussion like that. Okay. Great.
Wait, can you guys see it?
I can see it. I can see it. And this was the blue panel and the white panel also, so that you can you have the whole screen to yourself. Yeah. All right. So list. Yeah. Okay. Yeah. Oh, you do have top node and last node, and it's private. Okay. Because it's private, I think you may need to have getters for them. Saying in your public method, in your public methods, you may need to have get first node, get last node, and they just return these things. And you just complete them in line if you need. That's it. Okay. And go right to the end of this code, to the main, where we'll see we had a challenge thing there at the bottom. Yeah, first list, second list. Now make it. All right. So that's where you need to code after line 105. And so change the comment right to the top of the code saying class code for what is today's equinox, right? So it is spring equinox. Yeah. So 321. And say continuing code from last class to merge two sorted lists. Merge two sorted lists. Merge, and you can go to the next line because you see the thin vertical line. Yeah, two sorted lists. Yeah, TW merge TWO. Yeah, and you can put a space in front of the two, and I think that's good. And so I looked at the code and it seems all fine. So if you guys are confident, I would like to leave this in your hands, and I'll be on standby. Okay, I'll just be on standby, waiting for me to be called. Otherwise, I'm just going to be listening to the discussion and hearing you guys making progress. Okay, it's okay if you get it wrong. It's okay if you get it completely wrong also. Yeah, and because you're going to be iterating this code many times, and you'll find. Okay, all right. So I'm just going to be here. Okay. Oh, weather alert. Wow. Okay, cool. See you guys. Okay, 15 minutes. Just call me. Yeah.
So should we start down here?
Yeah, I think we can do it there. We might have to make like the getter for the first and last if we don't have it, but otherwise we can also make it in the class, I think. I don't think it's much of a difference.
So where should I start?
I guess if we're just making it outside, then we can just start by making like a getter for the top node and the last node.
Okay. The getter would be kind of. Would it be
I think we have to make it so like you have to in the definition do like it returns like a node and then like first node and then we just
Yeah.
return that.
Should I put it before these lists? I think so.
I think you can put it anywhere, yeah, as long as you also put it in the class definition.
Oh, okay. So let's do it for just do it right here. And in the class.
I guess like we could do like node star get top node because like we're returning a pointer.
Okay. And then something like.
Yeah, I'm not sure if we need the first top node, but I could be wrong. Just like node star, I think. And then like the same for the last, I guess.
And then, excuse me, for the getters, it would be what type of data type would this be?
I think it'll be the same, like node star, like
Nodes.
the pointer, and then you do like the yeah.
Would this just be like top node equals top node?
We might just like do something like return last node. And I think we have to put like the list colon colon, like
Oh.
I think in like the like node star list colon colon get last node. Like in the function. Like
Oh.
you like on line 51, like that. Something similar.
Line in after the return.
I think like on line 47, like
Oh.
after node star.
Okay. The parameters would be would it just be integer n?
I don't know if we need any because we're just returning something, right? Like we're not gonna use an integer for anything.
Oh, okay. I see what you mean.
Because I think the only reason we're doing this is because like it's private in the class. So then
Is it in the private one? Sorry. Oh, okay. Yeah. So then I guess we should start making our lists, or
yeah. Yeah, I guess like we can like make a function now, right? Yeah, I guess we could start off making like the list 3, like the new one.
like a new list. Wait, would this be in the main?
I mean, we can. I guess like we could write it in the main, or we could also make a function like outside the main that just takes 2 lists.
So then it would be string. Well, doesn't this one take? Oh no, okay. It would be so for doing 2, like it would be a string one. What should we call it?
Or maybe like merge, like combine, or like
Just
something
do
like that. Would we need the like the list colon in this? Because like if it's not like part of the class, then do we just like we
Oh,
don't
we'll
need
just
that, right? Yeah, and I think the argument would be like 2 lists.
we'll do. Would it be? List. I shouldn't be using these ones, right? Or I don't have to, because that's technically the name of the. Or should that be the name of the parameters
For what?
for these suggestions here?
I mean, it doesn't need to be the same. I think you just need to make sure to have the data type in front of it, but it can be any name. So like list my list 1 and then list, or list 1 and then list 2. And I think list is capital. And then we could probably make like a list 3.
We have to define it right now. And these are combining the two, right?
Yeah.
Would it be something like that? Or
I don't know if we could do that because like
it would be like something like a string, right?
well, I mean, the list itself is like an object. Like we could use the toString to make it a string, but I don't know if we can just combine like the plus with the plus. I think we might have to do like a for, like, because like if we like in the previous methods and stuff when we do like append and things, like it's like we go through and put it at the end. So we might have to do something similar, like if we're just like we start out with like the first nodes of both and then like put it to list 3, whichever one is smaller.
Okay, what should I type? No.
Maybe like a while, because I don't know how we would do a for 2. It's like while through true. Oh, we should probably like have pointers to the top nodes of both. So maybe like before the while we could have like node star pointer A is like the top, like get top node of list 1.
Node star. And then
Equals list 1 dot get top node.
what would be my list one?
I mean, it would just be whatever name is in the parameter, I think.
Oh,
I think we use a dot, not the star.
the dot.
Yeah, like the period.
And we will make the same one for the list too, right?
Yeah. I guess like one thing we know is that like if like the pointers are ever like null, then we can just break out like if the list doesn't have anything in it.
But that wouldn't be in the while true loop, would it be?
Like inside the while true, we could have like if pointer A equals null, like if both of I guess like if both of them are null, we would break out. Or like I don't know if we can, yeah, either that or like NULPTR.
So both of them, so.
I think it's the other one, the and.
So if both of them are null, and not just one of them,
Yeah, because one of them could be null. Like if they're not the same length, then one of them could be null before like the other one. Like if there's only 5 in one and like 10 in the other, then like the first one would become null at some point before the other one, right? So we still have to append the other one.
oh,
I don't know.
then maybe you said break out of it.
Yeah, just break, I think. And then I guess we could have like if we have like only one of them is null, and like then we would append like the rest of other ones. Oh, I think we need like the double equals for the when we're comparing.
This one too, right?
Yeah. And I think it's 2 ands for the first if, like it's 2 ampersands. So then if like the pointer A is like, so like if list, so then we would like list 3 dot append would it be pointer B dot data or like arrow data? And then we'd have to do like pointer B equals like the next pointer.
Wait, oh, so then pointer B equals,
Pointer B like arrow next.
I'm sorry, what did you say?
Like pointer B and like the arrow, because we need to use like arrows for pointer stuff.
Oh,
Or like, yeah, so like before that, be like pointer B equals that, like we're like reassigning pointer B. So yeah, I think pointer B equals pointer B arrow next. I think.
and then do we repeat it for pointer B, this if statement?
Yeah, I think we would do that. I think we need the curlies, right, on the ifs, because they're more than one line. Yeah, and I think like we should have covered with anything is null, so then we could just do like if like A's data is less than B's data, we like append A. Otherwise, we append like the B.
Yeah. Pointer A. Let's would it be pointer A data in the parameters?
Yeah. I think. And then like we have to like, I guess it's basically the same as like the last if, like whatever's inside the last if. So like we have to also do like pointer A equals pointer A next, right?
Okay.
And I think like wherever, I think it's correct. I think just we have to use the arrow. I don't know if we can use the dot when we're like doing like dot data, like arrow data. And also on like line 100 and 104. Oh, and then I guess like one edge case could be like if they're both the same, then like nothing's gonna append. So maybe we can make one of them like less than and equal to. Or we might just be able to change like one of the ifs, right? Like on either 107 or 111, or yeah.
This one need to equal sign too. Yeah.
And then are we returning a list or a string?
I'm not sure.
I guess we can just Yeah, we can just change the string to list if we're just gonna return a list. And then like in the main we can do like to list, I guess.
So this whole definition is done.
I think so. Does anyone else have any ideas?
That's right. I would just call this function, right? This merge list.
Yeah.
And then I use the my do I have to put list in front of it in the main too?
Sorry, what was that?
Do would I have to put list in front of the function in the main as well?
I don't think you have to
Okay.
if we're just calling it. I guess we can just like output it to see if it worked correctly. I guess we'd have, I mean, if we're doing it that way, would we have to like make a new list on 141? Like list 3 equals that, and then
Just to keep it equal
like the merge lists. Or like whatever was like online, like inside the merge list, we'd have to like call like my list, like it like past my list 1 and 2, right? And then like when we see out, just do like toString, like my list 3.toString. And like I think we need parentheses on the toString. I think we should be able to run it.
$47. What if need a date type?
I'm not sure. Hannah, is this how you did yours?
I mean, like I used the same structure, like I basically used the same structure, but I put it in, wait, where's it? Where's your guys', did you guys put, I put my function into the actual class.
Oh, okay. So you didn't use like a getter or
Yeah,
the other
I don't
one?
know. I also made everything public.
type should this be?
I'm not sure because I thought that would work. So I don't know like what it's asking for us to change.
Asking for a data type. So if we're returning a list, would it just be what is the node? The node is just like a value, right? So would it just be oh, I don't know.
Oh, maybe it's because node is inside list. So we have to do like list : in front of that too.
List
So maybe like try like list : node star. Like at the very beginning, add list :
well, it's in the private one, so should we move it to the public?
Yeah, I mean, I guess we can just move. We could just always move the last and the top node to public just to make it easier.
Yeah, that's what I did.
And then like we don't need the getter in that case, so we can just access it directly in like our function.
Just comment these out. Then we call.
Yeah, so instead of like get top node in the merge, we would just have to do dot top node. And then no parentheses because it's not like a. Oh, and then I guess we would have to do top node for both, right? Not last node for B.
Should I run it? Okay.
Yeah, we can try. Maybe we can just put we can just do what Hannah did and put it inside the class because I'm not sure how we would. I'm not sure what we have to do to like get node.
Put it in the class.
Yeah, so like we like in the class definition, we could just add the merge list and then just like make it a part of it. So like you could copy like the first line, like the header. Yeah. And like instead of the curly braces, it just be a semicolon. And then like in that, like when we go back down, we just have to do like the list colon colon. I think you need like two, like you have like list is the return type, and then you also have like a list colon colon. Or like, yeah, like it would be like, we put return type and then like the list colon colon. So like, yeah. That might work better. I'm not sure. It might be because of the parentheses and the merge is, or sorry, the curly braces is all the curlies like closed in like the merge function. Because I think we might be missing one for the while. Oh, we probably have to just return list 3 at the end of the after the while.
Oh, sorry. Well, actually, sorry.
Or I think it's because like on line 146, like the my list 2, the L should be capital. And I don't think we need line 145. We can just I think we can comment it out for now because
You don't need line 45.
I don't think so. Because like we're just calling merge in the next one again, right? Maybe try running and see now. Oh, I think you have to do list in front of my list 3. We have to put the list : in front of merge list. Oh, I'm not sure. Wait, Hannah, is this how you did it?
Wait, what? Sorry.
I think we put it inside the class, but when we're calling it, it's giving us this. So
Oh, wait, can I? Oh. Wait, why are you putting like a parameter of the list? Because it already has access to one of the lists, right? Or wait,
okay, so we just have to put like one of
I don't
only
know.
one
This
of
is
them.
not how I called it on one of the lists and I put a parameter of the other lists. I mean, also if you put your parameter, you need to put like the type of parameter it is. So it's going to be a list, right?
Yeah. Okay, so then like if we go, so then in the function, like we just, instead of doing like passing in both, we would just do like,
I just passed in one. I mean, you could pass in both, but yeah, you could. I don't know.
hmm. Okay, then I guess in like the merge, we can just, instead of passing in 2, we can just pass in 1.
In the merge, well,
So we can just like pass in list 2, and then for pointer A, we just have to do like top node because it's just within itself.
and then
And then pointer, like when it says pointer A equals, instead of list 1 dot top node, it would just be top node. And I think, yeah, and then wherever like, and then like in the class, we can just like change the header again. Like instead of passing in both, we just pass in 1.
could we still keep like this one too?
Yeah, I think we would still keep that one because we still need the other one. And then down there, we'd like delete that and then, yeah, and then call it with my list 1. or like we pass in my list 2, but then we do like my list 1 dot merge list on the line before.
Oh wait,
Yeah, we would, yeah. And then I think that would be 3, and then you go like a line up. Instead of list colon colon, it would be my list 1.
this all for my.
And yeah, I don't think we need the list colon colon anymore.
Could I try to run it?
Yeah, I think. Oh, it has to be capital L for my list 1.
Is this what we were looking for?
Maybe make the screen bigger, and then we might be able to.
Oh, sorry.
Did it print out the 3rd list?
No.
Hmm.
So I guess
I'm not sure.
it would. I think we might need to change this see out statement, but I'm not sure to what.
What will we change it to?
I don't know. Just I think alter it just to see out the list 3. But I thought that's how we would do it.
Like add like 3rd list or something?
Before that, like here.
Like you see how on like when we're printing out the other ones, we just do like first or like the 1st or 2nd list. So maybe just 3rd list to see if it's gonna print. And if it's not printing that, then it's probably something with our function. Oh, weird. Is it the indentation shouldn't matter, right? Like if it's
Let's Yeah, I don't think it matters.
yeah, I'm not sure. Does anyone else have any ideas?
Sorry for what?
Well, it's running, but it's not printing the 3rd list. So
Um, Wait, can I see the merge list function? Okay, could you scroll down? This is so weird. um, like, is it not printing that out at all? Third list equals?
Yeah, there's no third list equal on the screen.
Um, is it running into some sort of error when you're merging them then? Like,
What if I stuck this line over here? Well, you think that will make a difference somehow?
Well, I mean, if you run it and nothing prints out, then it might be like there's an issue with the function or
Yeah.
something.
Okay, yeah,
yeah,
you're right.
there's some sort of issue.
Let's move back.
You could put a try catch statement and then see if it works. Just like catch all the errors.
Where would we put that?
Like, I don't know. For like the like I don't think that's a really great solution. It's just like the first thing my mind comes up with. Um,
Is it something to do with our while? Like, is it just we have a break statement, right? Yeah.
I mean, like everything. This is like basically exactly the same that as I wrote. So I don't know what's going on. Oh, did you
Is it-
What
do?
if we change all these list threes to my list threes? Because this is like, because we're returning list three, and then is it like,
I don't think that should make a
No,
difference, right?
yeah,
Because
it's
they're
a
two different
separate-
variables.
not making a difference? Okay.
Is
could you
it because?
the
Sorry.
oh sorry.
Is it because like we have multiple? Like, should the ifs be like else ifs? Does that make a difference?
Oh maybe. Actually I don't really think it. What you can do is you can actually put the pointer a equals null pointer into the other if statement. So you don't need 4 ifs, you only need 2 other ones. You only need 3 ifs, you don't need 5.
So combine,
So null pointer a equals null pointer, and you can combine that with the last if. You just need to put an or.
so null pointer,
Or then the stuff for the last if.
or pointer B.
Yeah. Or you can just literally copy and paste that if header if you want. Yeah. Yeah, you can delete those. I think you need an else if for then you need an else if for the rest of them.
Make sure that I didn't delete an extra curly brace.
Okay, yeah.
Okay, so then it'll be
Yeah, you need an else if. Else it's going to be, oh no. You need to change the two other ifs to else ifs. Otherwise it's going to like, yeah. See if that works. Wait, scroll up.
we're still not getting the third list.
Okay. Can you scroll down? Huh. Could you scroll back up to the function? Okay, so we have list 3 top node, list 2 top node. Break, else if. How about right before the return? Could you just like print out like some sort of string? Let's like just see if it even gets there. Okay, yeah, there's like some sort of, oh, pointer A, so it's like not even getting to that statement. Can you put it like, could you put it on top? Is it like even getting to the whiles statement? Okay, yeah. So something is going on in there.
Maybe if you put it in like the first if, like to see if
Yeah.
it's gonna break.
Put this see out statement in the first if.
Yeah, like before the break. And then maybe I need a curly brace, I think. Oh, so it's
No.
not breaking.
Yeah. Oh. Maybe add an else statement and just like say next. No, wait, put that there. And then just like put an else statement down below.
Like continue or something.
Or no, just like make one of them, put both of them like put pointer A dot next. Just something.
Here.
Oh, no, don't put anything in the else. Just like down below, instead of the continue, put like pointer A equals pointer A dot next. Or just do what Namratha said, put a continue. I don't know. This is like, what is going on? Yeah. I guess to troubleshoot it, we could print the list 3 for every single time. Like put it in the, okay, wait, no. Could you put that instead of the else statement, like down below? Here. Oh, wait, no, could you take out the else statement and like just like put it down at the end of the for loop, while loop? Could you do list 3 and then another, and then could you print out list 3 as like to 2-string? Yeah. Try running that.
Oh, no, we have two. Oh, we have multiple of them.
Okay, so when does it like stop? Okay, it stops when it's 41. Why does it stop when it's 41? Shouldn't it stop when it's 47? Yeah. There's something wrong with the Boolean log, or just the operator logic. Can you zoom into the else if statements, please?
Zoom in.
Yeah, I can't really see it very clear. Okay. Oh, could you remove one of the equal signs for the first one? Oh, no. Oh, for the after the or statement for the second else if, could you remove one of the equal signs?
Okay.
Okay, else if, I mean, it shouldn't make a difference, but like. Wait, okay, for the first, I'm just gonna do what I put. For else if, could you remove that first equal sign? Oh, no. For the first else if statement, could you remove the after the or and put it down to the second one? And then could you add an else statement? And just copy and paste what you have like above there, like here. No, for the list 3 dot append. Like just that. Yeah, and I'll try running it.
I think you need the curly braces before.
Oh, right. Wait, can you show them?
Now let me make it bigger.
Okay, it's still stopping at 41. I think it needs to stop at 47. I'm like pretty sure.
Well, that's because we're like printing it after,
Yeah.
right? Like you don't print it like the breaks after, so we don't print the last thing.
Okay.
But it's not like printing in the main either.
Yeah. I mean, it seems like it's not like it doesn't seem to be like running into an error per se, so I don't know.
Do
Maybe
you guys want
can
me
you
to take a look?
yeah.
Yes, please.
Sorry. I like
Sure. Well, you know what? You could have called me anytime too, right? So you don't have to. You can say, hey, okay, all right. So what are we trying to do here? What is the method? All right, merge lists, and you're
Yeah, I
given
think
list 2. Oh, and you made it a method. Okay, you made it a method, meaning that you're in a list and you're given a new list that you have to merge into the current one. Is that right? Is my understanding correct? Okay, good. All right. So node pointer A is the top node of your own list. Node pointer 2. B is the top node of the second list, okay. And while true, that's good. If pointer A is, okay, so if they're both null, you've reached the end of the 2 lists, that's good. If A is null and B is, all right, list 3 dot append. I see. Okay. Okay, all right, good. All right, so you have the high level detail correct, okay? You have the high level detail correct, and this should work. I understand you guys are fighting a bug right now, yes? Okay, good. So I'm not going to fix the bug for you because I think it is a juicy opportunity for you to dive in. Also, one of the other reasons is because I thought we should have at least 5 minutes to look at Hannah's code, and she asked for some stylistic changes and all, so we can look at that too, which will be useful generally for everyone. Okay.
Oh, Professor, I think I just like tried to help by like doing my code, and I think like I don't know, that was the stylistic concerns, or like just the concerns I'd like to address. I think I like basically I asked Sabrina to change it to model my
Oh,
code.
it's changed now?
Yeah, I think I was kind of confused about some of the logic stuff, so I added this extra else statement into my code. I don't think it's necessary, but like
I see. But you said it worked before, but after the change, it doesn't work anymore, does it?
oh no, my code works, but I think I don't
Oh, so
know
this one, you're talking about this code. This code,
Yeah. 'Cause this is, like,
after some
basically
change.
what I did. I don't know.
I see. Okay, now so how about this? Before we look at your code, if you want us to look at it together for stylistic changes, we can do that. Before we do that, why don't I describe a simple way to do this? You can either fix the bug here and do it, that is fine too, or I can describe another method, and we'll also lay the groundwork by doing a few things. Okay, well, maybe I'll give you the shell of the outline of the code, and you can just fill it in. How about that? Yeah, it's another one. So let's put this whole thing in comments. Okay, put list : merge lists. Okay, in comments, block comment. No, put a block comment on the top. Go to the previous line. Yeah, actually go to the previous line. It's easier. Go to the previous line. Yeah, hit enter. Okay, and yeah, all right, so good, and black. All right, so now yeah, and put a no, the other way around, // and also go to the top of right after you open the comment, and let's put a comment there. Okay, on line 93, hit enter. Okay, so start a comment there saying this code is good. You just need to fix the bugs. That's your homework. Okay, it's a simple bug. There's some simple bugs in there. You can just need to fix some bugs, fix the bugs and share. Okay, fix the bugs and share. We'll do another way, which is also going to be okay. So let's go. So let's do something very similar to what you guys have been doing. So here, and I'll describe the strategy. And everybody tell me if the strategy makes sense. Right? If the strategy makes sense, you're good. Yeah. Okay. So so we have a list, and you're given a new list. Okay. Now the thing is, let's not create a brand new list, because you have a list and a new list has been given. And let's say that our method is basically just going to dismantle our parameter of the argument list, take all its nodes, right? Cannibalize all its nodes and stick them in our list at the correct places. Does that make sense? So that at the end of the method, your current list would have all of the elements, the other list would be empty. All right, so now raise your hand if this makes sense. Okay, good. So that's what we'll do. So let's create we'll create a method. How about we say it's void? Okay, let's say void. Yeah, so type void space, and then say list : and let's call this method merge list into, right? Merge list into. I just call it merge sorted list into self. Merge sorted list into self. Okay, into self. Yeah, merge sorted list into self. So the name is kind of self-explanatory. You can change all these things later on. Okay, and the parameter is going to be a list. Okay, parameter is going to be, call it list, uppercase list space that list. Okay, and no, ampersand. You're going to pass the other list by reference. Okay, so ampersand, and then one ampersand, only one ampersand, and say okay, and call it that list, not just this list. Just call it that list instead of list. That list. We'll call it that list. No, not dot list. Okay, that list. That one. Okay, that THAT. Instead of the dot, say that list, that underscore list,
Oh, that.
or other list. Call it other list. Call it other list. Call it a list, other underscore list. Okay, great. Right now, I can curly brace at the end and close the curly brace, and we'll put a comment on top of this method so it's clear what it's doing. So that because this method will not be complete, right? It's going to have a lot of to-dos for you to fill in and share in the forums. So what this does is merge all the nodes, insert all the nodes in the other sorted list into our list in the correct order. Insert all the nodes. Yeah, that's fine. So, all the nodes in other list. List, one word. Yeah, singular, right? Into our current list. Right? Yeah, I think, yeah. Oh yeah, into a current list in the correct order, in the correct order. And then on the next line, we'll continue the comment, right? When this method completes, other list will be empty and our list should have all of the nodes. Does that make sense? Because it's going to be essentially what we want. That's what we want to do, right? So here is our method. So inside, yeah. So on line, go to 128 and hit enter. And by the way, if you're not able to figure out the bug in what you have written, it is pretty straightforward, right? I'm pretty sure one of you will figure it out. If you're not able to figure it out, just send me a Reddit message or an email or something, and say, hey, Prof, can you weigh in on the Reddit and tell us what the bug is? And I will post a comment on the. I won't post a comment if nobody, if I'm not asked, because someone might be working on it and they might be close to a solution too, right? So I won't post a comment saying this is the bug. But if you want me to post a comment, I will do that. Okay, so I'll just take a look and say this is what you need to change, and it'll work. Okay. So now here is the thing we want to do. So now let's say, what is it? Node? Yeah, list : node, list : node. Or you can just say node because this is a method, right? Node, space star p, right? Node star p equals, space equals space, right? Other node. Other list dot get first node. Okay, and this is a method you have to implement. And so you can, so we can do that in like 1 second. So go to the top, and also before you do that, triple click on the that merge sorted list. Triple click on that and copy that. Okay, because we need to put that also in the header, right? So copy that. Go to the list class. Go to the list class.
I think we tried these getters earlier.
Oh, put them back, right? And also, and let's not call it top node. I thought we changed it to, well, just the second method. Get this for the second method. Just say get, what did we call it? Last, get first node. I think, what did we call it? Did we call it get first node?
Yeah.
Yeah, okay, good. Right, so that's it. And you have it declared in the class and all? Great. All right, so now on line 31, hit enter on line 31. Hit enter. Now paste what you have. Right, now get rid of that void list : no, get rid of the list : get rid of the list : yeah, okay, and then put a semicolon at the end. Okay, and you can comment out line 34 for now, because that is your homework, right? So you can put a comment there. Yeah, and then put a comment at the end also, at the end of the line, saying has bug, homework, fix and share. Okay, has bug, fix and share. Okay, now let's go back to our method now. So, all right, so now put a semicolon there, right? Now enter. Well, okay. All right. So also you say node star q equals this arrow get first node, or you can just say this, get first node, automatically is on this too. That's fine. Get first node. Okay. So we have 2 pointers. One of them is pointing to the first node of the other list, and the other one is pointing to the first node of our list. Yes. Yes or no? Okay, great. All right. So now, now let's open a loop. And say while p is not equal to null, right? So while p is not equal to null pointer, right? Enter, enter. While p is not equal to null pointer. Yeah, space on both sides. Yeah. No, not there. Right now, and in the body of the loop, Okay, great. Now here's what we want to do. First, the first thing we want to do is extract the first node, extract the list, extract that thing out of the first out of the other loop. Yes. So all we're going to do is we're going to say, well, you know, we don't have to extract it really, because we are already pointing to the first node. So what we want to do is make a comment there. Make a comment there, saying now, right? Skip all elements in the current list. That are less than p, or p arrow data, right? Less than p arrow data. Was it p arrow data? I don't know. What is it? Yeah, p is the node, so p arrow data. Yeah, p arrow. No, I'm not arrow. P arrow data. No. Dash greater than. That's the arrow. Yeah, it's yeah, there. Okay, so this is what you have to do here. You have to have an inner loop there. Okay, so you're going to say, yeah, here you're going to have a for loop or something, right? So you can basically just do a while loop there too, right? So you can say while q arrow data. Say it's while q arrow data, q arrow data is less, oh no, what is it? Is less than p arrow data, right? So we want to skip everything that's less than and then add it there. Okay, less than p arrow data, right? All you have to do now is in the body of the while loop, you're just skipping. What do you do when you want to skip the elements? You say q equals q arrow next. Yes, that's all, right? So that's the body of this while loop. So on the next line, you have to indent in and say q equals q arrow next. And now we have to be careful here, because you know, q could suddenly be null, or null, you know, q could be a null pointer at some point. Yes, it could reach the end of the list and be a null pointer. And if you say null pointer arrow data, your program will crash. So in the while loop on 135, on line 135, at the beginning, after inside the condition, and say while q is not equal to null pointer, while q not equal to null pointer, and right, double ampersand. Okay, so that is our safe statement, saying, well, you know, I'm holding on to the second list, and as long as it is not a null pointer and that element is less than that guy, I'm just going to go on to the next one. Now, is everybody okay with this? Because, you know, this is nested loops, we're working with 2 loops at a time, and we're skipping elements, you know, moving things around. There's actually, you know, almost 2B level stuff here. Okay, this is 2B level stuff. If you're comfortable with this, you know, you have an easy time in 2B, really, because we're doing a lot of things here. It is like super duper important to get utterly comfortable with this code. And, you know, at the end, we'll have corner cases and bugs, right? And so you know, it's not finished until you fix all the bugs. And in fact, the learning will happen when you fix the bugs eventually, right? So, but I want to make sure that everybody's on board and everybody happy with this so far, right? We're just skipping. Now we've got to the place. Hang on just a sec. Q is all right. So now the Q's so the current element is greater than, which means that element has to go before it. Yes. Okay. So here's the first problem, right? So we have this. We have an element come in, and this is our pointer. We've advanced it continuously until a point where we get a node which is in fact greater than or equal to, right? This node is greater than or equal to that thing that there, you know, is there. So essentially what we want to do is insert that node before this node, because the list has to be in sorted order. Yes. Right. So some of you are still thinking. So let's say 1, 2, 3, 4, 5, and let's say, well, let's say even numbers. Okay, 2, 4, 6, 8, 10. Right, and then 3 comes along, and you need to insert 3. Right, that's 3 is the node that you need to insert. So you're going from 2. 2 is less than 3, so I'm going to go to the next node. Right, 4 is greater than 3. So where should 3 go? 3 should go before 4, not after 4. Yes. Okay, so that is the first problem here. So you need to figure out a way in which you can now see the thing is you're holding on to this node, but you need to put that node before this node. But how do you get before the node? Because you've given up the pointer to that node already. Yes. So here's where you need to adjust, right? So let's put on line 134. On line 134. Okay. Hit at the end of that line, hit enter, and say the following. What's the following loop? Comment. The following loop, okay, will not work because we'll call it the cursor. Okay, we'll call it the cursor. So the node that needs to be inserted needs to go before, not after the node we're at. Okay, so you have to figure out a way in which you can take that node and put it before. One way to do that is always to stay one step before. So rather than checking Q arrow data, you're going to check Q arrow next data. Okay, now does it make sense? You're going to check Q arrow next data, not Q's data, because if Q arrow's next data is greater, then that is going to be here, and that is going to be linked in. It is a mental picture. I wish we could. This is the first time actually that I wish I had a whiteboard. Okay, in several quarters, because a picture, maybe Namrata or someone can make a nice picture and share. Okay, because it'll make it very clear. So the picture is worth 1,000 words here. What we're saying is that this node comes along, needs to be inserted in the current list, and I've found the point where it needs to be inserted. However, that node needs to go before this point, not after. Now at this point, I'm only pointing to the next guy. I'm not pointing to the previous guy. But the previous guy's next is what needs to point to me. Yes, if my current node is going to be stuck in there, the previous guy has to point to me, and I have to point to this guy. Yeah. Okay, so that is basically what we want to do. So so here, one of the ways I wonder, should I do this or should I not? Okay, how about this? Well, we'll get as far as we can. If you cannot do this by Thursday, I hope someone can do this by Thursday. If you cannot do this by Thursday, first thing we'll do on Thursday is just fix the code, write out this function. Okay, but you have until 2 days. Because it's all list pointer manipulation, it will take you a little bit of time. So that's why you have this 2 days to figure it out. We're going to do more, okay, before I hand it over to you. But this is what you need. I'm putting some notes in the comments for you to help you when you're doing this. So, but we will fix this on Thursday and do the complete version and working version. Okay, so what we need to do, so the following loop, because a node that needs to get inserted, the node that needs to get, because a node that needs insertion on the next line needs to go before, behind, or behind the current node and not in front of it. Right? And the next line, maybe I'll give you one more hint. Okay, one more hint. This means we always need to work with Q arrow next data rather than Q arrow data. Okay, that is the most important part. Okay, so the most important part of that hint is there. The hint is that we need to work with Q arrow next data. However, if you're working with Q arrow next data, you have some corner conditions and you say, well, you know what, Q should not be null and Q's next should also not be null, things like that. You got to figure that out. But when you draw a picture on paper and see this is what I need to do, it'll be 100% clear, okay, what we need to do. All right, so now, so after the while loop, after the, and put a comment, the curly brace, right? Q arrow. Oh, no, not there. You've got to the place, okay, you've got to the place. So after 139, hit enter. right? Yeah, one more, and then yeah, now back. Right. So now start a comment there, saying, right? We've arrived. So put say we have arrived at a spot, at a node. No, we have arrived at a node. We have arrived at a node where P needs to be inserted behind us, not in front of us. That is a key. Okay, behind us, not in front of us. So how do you now? I'm not going to go into the detail of how you do this, but I'll give you the basic idea here. And obviously this is going to be on recording. It's going to be recorded. You can refer to the recording too. And this code is going to be there, and it's a comment there. So how do you P is there, and how do you have to unlink P from that node? Okay, to unlink P from that node, you got to do two things. One of the things you got to do is go to the next line. Go to the next line, right? So step one, right? So yeah, in an open comment, say step one, unlink P from that list. Unlink P from that list. Right? No, that underscore list. That's a parameter. No, other list, not that list. How do you do that? How do you unlink P? All you have to do is basically say, my first node, because you've taken off the node, my first node is actually P arrow next. So you can say within parentheses, you can say other node first is now P arrow next. Other node first, first node, right? Other underscore node. I think other list, underscore other list, arrow first node, or dot first node. I think dot first node, because it's it's not a pointer. First node is now P. Yeah, and on the next line, step two, right? Connect P into this list behind us, right? Behind us. This is the hard part. You have to connect that node behind us, not in front of us. Connecting front is easy, isn't it? Connecting a node in front is very easy, because you get a node, and you need to connect it to the front of this list. It's all I have to do is take my next pointer. Okay, I store it somewhere. Okay, and say, well, my next pointer used to be pointing to Hana, right? It's not pointing to Hana anymore. My next pointer is now pointing to Namrata, because that is a node that needs to get inserted. Yeah, and who's Namrata pointing to? Namrata is pointing to Hana. Now is right now this list has got Namrata inserted before Hana. Yes or no? So exactly the same strategy. This node needs to go behind us. So all you have to do is, that is the way you unlink it. You unlink it, put this node, and this node's next is going to point to this. That's all. Now, does that make sense? And you do this all the way, right, until the other list runs out. Until the other list runs out, and you've got that list merged into a current list. And in linear time, just like Hana's code, it is also in linear time. The only advantage here is that we're not wasting memory by creating a third list. Because in the other way, it's same time complexity, but it's worse space complexity in the other one. That's all, right? Because in the other strategy, we're taking two lists, we're merging them and giving you a third list. But here we're saying, don't bother giving a third list. You just take that list and merge it into the current list. And it's still doing it in linear time, because if these are the two lists, and these are two pointers initially, and you're saying, well, I'm going to take the first element from here and go to this list, and I'm going to check where it needs to go. Oh, it needs to go here. So I'll insert it there. Insert it there, meaning behind that node. Okay, and remove that thing from the first one, and then go to the next one, and so on. Right? And essentially, all you have to do. Right, and then you advance P, right? And then you advance P to the next node, right? Advance P to the next node. Now, the next line behind us, yeah, and then you set P to what P pointed to. So set P to what P pointed to. Okay, here. All right, so I think that is basically it. I don't know how much more information you need, but depending on time, we will actually continue to implement this until the end of class. Okay, what time is it? What time is it now? Oh, it's 10:08. Okay, so yeah, I should have come back a little sooner. Well, you could have called me too, right? So, but the reason I didn't come back sooner is because I could see that you guys are having an interesting and good conversation. Because you're running into problems and asking each other and trying to solve. That is 100% better than me telling you or anyone telling you this is how you do it. So discussion is always better. It trumps, for me, it trumps an actual lecture anytime. But I'm happy to. We will complete this class, this method next class. Yeah, you're going to share it, obviously. Thank you. Right. Before you we'll take a look at a quick look. All right. So okay, let's take a quick look at the code again. I just want to make sure if all the information is there that you need. Okay, now skip all the elements. All right, and you're grabbing that element and you have to insert it in there, and oh yes, set P to what P pointed to before, right? So it advances. So all right. So anyway, it's working in my head. Okay, this strategy that I outlined is working in my head. But however, that's not the pudding, right? The proof is in the pudding. You see, because always we find code works in our head, but when we code it, it doesn't work, right? It works, and so it's possible that after we code it, we may have some bugs, and which is exactly the same. Whether even when you code it, you're going to have some bugs, and the fun part is going to be figuring out where the bugs are. But in order to be able to figure out where the bugs are, you just need to understand the overall strategy. Now, hands up if you understand the overall strategy. All of you, right? I cannot see Sabrina, Simon, and Matt, but just hands up, or give me some feedback saying if you understand the overall strategy. So this is what we want to do. We're going to go step through. Extract, basically peeling off nodes. Thank you guys. Okay, we're going to take out a node from that list, and to take out a node, all you have to do is just pull it out and set the first pointer to the next one. That's all, right? When you take a node out, you're going to say, oh, my first is not the first node anymore, but the first node is gone. My first node is now the second node. Yeah, my first node is the next of the first node, and you keep doing that until the other list runs out. And when the other list is run out, you say, well, all of those nodes have been inserted into the current list, and you're done with the merge. Now, is that okay? If that strategy is okay and it makes sense, try and implement it and share it in the forums. And if not, we will complete it next class, but I'm hoping we won't have to, right? Because I'm hoping that some of you will actually complete it and share it. I'm pretty sure Hannah, who's already done that code, will find it's a very simple change, okay? Very simple change to what you've already done to make it conform to this. And if you guys are interested, we can look at Hannah's code. I actually looked at your code, Hannah, right? Stylistically, it seems it's mostly okay. It looks good. It's naming. I think you call it merge lists or something, right? Yeah, and I think that is good because you're taking two different lists and returning one. But because the one stylistic comment I would make is that hey, Namrata, if you share Hannah's code for a second, right? I'll just say that the one small stylistic change, which will be very useful as you implement your own methods too. Namrata, if you can share Hannah's code for a second, I'll show you what I mean. Okay, so because you're taking two lists as a parameter and delivering a third list, it does not make sense to make this method a member of any particular list, because you're taking two lists and they're both equal, right? They're both equal. So it does not make sense to make this a member of a list. So you can basically say it is a global function at this point. It is not a member function. It's a global function that will make it cleaner and more symmetric, right? Because both of them have equal power. So it's a global function. It takes two lists and it's going to manufacture a third list and it's going to return the third list. And I think that is the only stylistic change I actually had. But if we take a look at the code, I can also say, hey, Namrata, if you don't mind, can you click on Hannah's link? I just want to make sure.
Who's sharing?
Oh, Sabrina. I thought Namrata was coding. Hey, Sabrina, are you here?
Yeah. Sorry.
Yeah. So just click on click on Hannah's code for a second. Is it okay with you? You guys are, it's past 10 o'clock here. But many of them come here now. Look at that. Yeah.
Soon.
Sorry?
I have to get going to school soon.
Oh, you're gonna go. All right, yeah. I know. Namrata, thank you so much. Okay. Well, he's gone. Right. So, all right. So you can take off. But the only thing, click on her code. Click on her code really quickly. This is just one small thing that I want to say. Click on it. Yeah, and then go to the last, the end. She has her method at the very end.
I'm sorry, did it like a million times.
Oh, you done it? All right, okay. All right, right to the end, right to the end. A little bit more, up, right. But no, more. I want to see the method that, yeah. Combined. All right. So yeah, you're going to call it combined two lists, and you're going to give it list 1 and list 2 as 2 parameters, 0.1, 0.2. Oh yeah, instead of 1 double equals 1, you can just say while true, which is what you used in the current code. Yeah, 1 double equals 1 is because 1 double, yeah, right. So right, 0.1. Otherwise it is fantastic. Okay, good job, good job. And you just need to make these changes, and now implement the other way, the way that we did it in class. Do it the other way, and say, well, you know what, you're just going to peel it off and come. Well. All right. So thank you all so much for your time, Hannah, and Hannah, thank you for sticking around. And apologies to your next professor, teacher in school. Okay, and so I'll see you guys on Thursday, and I hope to see some code before then. Okay, and if you and we can look at the code, and if you have some code that already works or partially works, we can correct that, or we can just fix this up. Right. So was the class today especially useful for you guys? Because I wasn't present most of the time. You guys were teaching each other and experimenting and playing around. It was like a playground. Was this a useful use of time today in class? No.
Yep.
Okay, good. All right. So I was just worried because I wasn't here, and I thought, without, yeah. All right. So that's fantastic. I'm very pleased to hear that. I'm looking forward to seeing you all on Thursday, because that's potentially the last time I'll see you this quarter. Yeah. So please come to class, let your classmates know also, and work on the code. Keep coding. All right. Thank you all. All right. I'll see you guys. Bye.